Welcome. In this video, we'll explore the various Route 53 routing policies and how they help optimize traffic management for your applications. Routing policies in Route 53 define how the service responds to DNS queries. It's important to note that the term routing in this context is different from traffic routing in a load balancer. Here, routing refers specifically to how DNS queries are answered, not how traffic is routed. Route 53 supports several types of routing policies to address different use cases. Simple routing used for single resources performing a specific function, for example, a web server hosting a website. Weighted routing to distribute traffic to multiple resources based on assigned weights, allowing fine-grained control over traffic distribution. Failover routing for disaster recovery scenarios configures active-passive failover, ensuring traffic is routed to a secondary resource if the primary one fails. Latency-based routing routes traffic to the region or resource that provides the lowest latency to the user, ensuring better performance. Geolocation routing serves users based on their geographic location, routes traffic based on the physical location of users. Geoproximity routes traffic based on the location of resources and users, with the option to shift traffic between regions. Multivalue answer routing provides improved availability by returning multiple IP addresses. Returns up to 8 healthy records selected at random, improving availability by balancing responses. Let's take a look at the Route 53 simple routing policy. This is the most basic routing policy in Route 53. It's designed to route traffic to a single resource, such as a web server hosting your website. With simple routing, you typically use an A record to resolve the resource without applying any advanced rules or configurations. It's important to note that this policy does not include advanced features like weighted or latency-based routing. Instead, it provides a straightforward way to configure standard DNS records for simple use cases. This diagram illustrates how the simple routing policy works in Amazon Route 53. In this example, we have a client trying to access a domain, example.com. Using Route 53's simple routing policy, the DNS query resolves to a single IP address. This type of routing is straightforward and ideal for simple use cases, where traffic is directed to a single resource, such as a web server or an application. There are no additional routing rules or conditions applied. The simple routing policy is a reliable way to configure standard DNS records when advanced routing features like weighted or latency-based routing are not required. Let's discuss the simple routing policy for multiple values. First, you can specify multiple values within the same DNS record. If multiple values are returned, the client selects one randomly, which helps distribute traffic across those values. When using an alias record with the simple routing policy, you only need to specify a single AWS resource, simplifying the configuration process. However, it's important to note that health checks are not performed with this routing policy. This means Route 53 does not monitor the availability of the resources associated with the record. The simple routing policy is ideal for basic use cases without the need for advanced health monitoring or traffic distribution logic. This diagram illustrates how Amazon Route 53's simple routing policy works when multiple values are specified. In this example, the client sends a DNS query to resolve the domain example.com. Route 53 responds with multiple IP addresses, such as 93.184.216.3493, .84.216.35, and 83.1E4.216.36. The client then randomly selects one of these IP addresses to connect to. This approach is simple and helps distribute traffic across multiple endpoints without applying any advanced routing logic. However, it's important to note that no health checks are performed in this configuration, meaning Route 53 does not verify whether the IP addresses are functional before responding. This makes the simple routing policy ideal for basic use cases where traffic distribution is randomized and health monitoring is not required. Let's explore the weighted routing policy in Amazon Route 53. This policy allows you to associate multiple resources with a single domain, such as example.com, or a subdomain, like acme.example.com. What makes this policy powerful is that it gives you control over how much traffic is routed to each resource. By assigning specific weights, you can distribute traffic in the proportions that best suit your needs, making it ideal for scenarios like load balancing or gradual feature rollouts. This is achieved by assigning a relative weight to each resource. For example, you can control what percentage of DNS queries go to specific resources by adjusting their assigned weight. It's important to note that the total weight doesn't need to equal 100, making it flexible for various traffic distribution scenarios. This routing policy is ideal for use cases like traffic splitting during application testing or gradual feature rollouts. This diagram demonstrates how the weighted routing policy works in Amazon Route 53. In this example, we have 3 EC2 instances, each assigned a specific weight. The weights determine how traffic is distributed among these instances. The first EC2 instance has a weight of 70%, meaning it receives the majority of the traffic. The second instance is assigned a weight of 20%, receiving a smaller portion of the traffic. Finally, the third instance is given a weight of 10%, receiving the least traffic. When a client makes a request to Route 53 for the domain, Route 53 uses these weights to distribute traffic in the specified proportions. This policy is ideal for scenarios like load balancing, testing new deployments, or gradually rolling out updates, as it allows precise control over traffic distribution. Let's explore some key points about the weighted routing policy in Amazon Route 53. To stop sending traffic to a specific resource, you can assign it a weight of 0. Interestingly, if all records are assigned a weight of 0, traffic is distributed equally among all associated resources. For DNS configuration, all records in the hosted zone must have the same name and type. Additionally, each record can be associated with a health check to ensure only healthy resources receive traffic. Typical use cases for weighted routing include load balancing traffic across AWS regions, A/B testing to evaluate new application versions by gradually routing traffic to them. This policy provides great flexibility for distributing and managing traffic in dynamic environments. Let's take a closer look at the latency routing policy in Amazon Route 53. The primary purpose of this routing policy is to minimize round-trip time and ensure the best latency for users by directing their requests to the most efficient AWS region. This policy is especially useful when your application is hosted in multiple AWS regions. By automatically routing users to the closest resource with the lowest latency, it significantly enhances overall performance and user experience. The latency routing policy is an ideal solution for improving responsiveness in global applications where performance is a critical factor. Let's take a closer look at how the latency routing policy works in Amazon Route 53. First, you need to create latency records for your resources across multiple AWS regions. These records define how Route 53 handles queries for your domain. When a DNS query is received for your domain or subdomain, such as example.com or acme.example.com, Route 53 identifies the AWS regions where latency records exist. It then determines which region offers the lowest latency for the user. Once the optimal region is identified, Route 53 selects the corresponding latency record for that region and responds with the resource's value, such as the IP address of a web server. Additionally, latency records can be associated with health checks, ensuring only healthy resources handle traffic. The policy also supports failover capability, adding an extra layer of reliability for your application. This diagram demonstrates how Amazon Route 53's latency-based routing policy operates to optimize user performance. In this example, we have 2 application load balancers, ALBs, one hosted in the US East 1 region, and another in the AP Southeast 1 region. When a user sends a DNS query, Route 53 evaluates the latency between the user and the AWS regions hosting these ALBs. For example, users in North America are directed to the ALB in US East 1, as it provides the lowest latency for their location. Meanwhile, users in Asia are routed to the ALB and AP Southeast 1, ensuring the fastest response times for their region. This policy ensures that users connect to the AWS region with the best performance by minimizing round-trip latency. This improves the overall user experience and makes latency-based routing an ideal choice for applications hosted across multiple AWS regions. Let's explore the failover routing policy in Amazon Route 53. This policy allows you to route traffic based on the health of your resources. If the primary resource is healthy, traffic is routed to it as expected. However, if the primary becomes unhealthy, the policy automatically redirects traffic to a backup resource. Failover routing is ideal for active-passive failover setups, where you need to ensure high availability and reliability by seamlessly switching traffic to a backup resource during failures. Failover routing is ideal for active-passive failover setups, where you need to ensure high availability and reliability by seamlessly switching traffic to a backup resource during failures. This diagram illustrates the failover routing policy, specifically an active-passive setup in Amazon Route 53. When a client sends a DNS query, Route 53 checks the health of the primary resource, such as the primary EC2 instance. This health check is mandatory to monitor the availability of the resource. If the primary EC2 instance is healthy, Route 53 routes the traffic to it as expected. However, if the health check detects that the primary resource is unavailable or unhealthy, the policy automatically redirects traffic to the secondary resource, which acts as the disaster recovery or backup instance. This ensures high availability by seamlessly shifting traffic to the backup resource when the primary instance fails, making the failover routing policy ideal for disaster recovery and critical applications. By leveraging health checks and active-passive failover, this policy provides a reliable and automated solution for managing application downtime. Let's start by understanding the geolocation routing policy in Amazon Route 53. This policy enables Route 53 to respond to DNS queries based on where the user is located geographically. One key difference between the geolocation routing policy and the latency-based routing policy is that geolocation routing is based on the user's physical location, not performance. When configuring the policy, you can specify user locations by continent, country, or even a U.S. state. In cases where there is overlap, the most precise location takes precedence. To ensure all users are handled, it's also important to create a default record, which acts as a fallback for unmatched locations. Now, let's look at the features and use cases of the geolocation routing policy in Amazon Route 53. This policy can be associated with health checks, ensuring that traffic is only routed to healthy resources. There are two primary use cases for the geolocation routing policy. Content localization. You can use this policy to deliver localized content or present your website in the user's language, enhancing the user experience. Content restriction. It's also useful for restricting content distribution to specific geographic locations, ensuring compliance with distribution rights. These capabilities make the geolocation routing policy ideal for tailoring content delivery to meet both user preferences and regulatory requirements. This diagram illustrates how the geolocation routing policy in Amazon Route 53 operates. In this example, the DNS routing is based on the geographic location of the user making the request. Let's break it down. A user from California is routed to an IP address 98.12.23.65, which is specifically configured for that region. Similarly, a user from Ohio is directed to another IP address 23.34.54.72. For users who are not located in any specified region, Route 53 uses the default record. For example, if a request comes from a location without a matching geolocation rule, traffic is routed to 54.24.36.78. The geolocation routing policy ensures that content is tailored to the user's location, improving performance and enabling features such as localized content delivery or regulatory compliance. Additionally, this policy can be associated with health checks, ensuring that only healthy resources receive traffic. Let's start with an overview of the Geoproximity Routing policy in Amazon Route 53. This policy routes traffic based on the geographic location of both users and resources. It gives you the flexibility to prioritize specific resources by shifting traffic towards them. A key feature of the Geoproximity Routing policy is the ability to adjust traffic flow by expanding or shrinking the geographic region assigned to a resource. This allows you to manage traffic distribution dynamically, ensuring optimal resource utilization. Now, let's talk about configuring the Geoproximity Routing policy in Amazon Route 53. To adjust traffic flow, you can use bias values. To expand a region and increase traffic to a resource, set a bias value between 1 and 11. To shrink a region and reduce traffic to a resource, set a bias value between 1 and 99. This policy supports both AWS resources and non-AWS resources. For AWS resources, you specify the AWS region. For non-AWS resources, you use the latitude and longitude of the resource. It's important to note that to use this feature, you must configure it through Route 53 traffic flow. This diagram illustrates the Geoproximity Routing policy in Amazon Route 53. In this example, we have two AWS regions, US West 1 with a bias of 0 and US East 1 with a higher bias value of 50. The bias value in US East 1 expands its geographic region, directing more users to connect to resources in that region, even if they are closer to US West 1. Geoproximity routing allows traffic to be dynamically shifted based on these bias values. For instance, a positive bias, like the 50 in US East 1, increases the size of the region, drawing more traffic. A neutral or lower bias, like the 0 in US West 1, keeps traffic within its default boundaries. This feature is especially useful for scenarios where one region has greater capacity or needs to handle a larger share of the traffic. Geoproximity routing also works with non-AWS resources by specifying their latitude and longitude. To configure this policy, you must use Route 53 traffic flow, which provides an easy way to manage traffic distribution across multiple locations. Let's explore the Multivalue Answer Routing policy in Amazon Route 53. This policy is designed to route traffic to multiple resources. A key feature of Multivalue Answer Routing is its ability to integrate with health checks. Only healthy resources are included in the responses to DNS queries, ensuring better reliability and performance. Let's understand how the Multivalue Answer Routing policy works. For each DNS query, Route 53 can return up to 8 healthy records from the available resources. This ensures that only healthy resources are included in the response, improving reliability and performance. However, it's important to note that the Multivalue Answer Routing policy is not a substitute for an elastic load balancer. While it provides basic traffic distribution, ELBs offer more advanced load balancing capabilities. Let's quickly summarize the various routing policies available in Amazon Route 53. Simple. Routing policy. Ideal for routing traffic to a single resource, such as a web server hosting your website. Failover routing. Policy. Ensures high availability by routing traffic to a secondary resource when the primary one fails. Geolocation. Routing. Policy. Routes traffic based on the user's physical location, enabling localized content delivery. Geoproximity routing. Policy. Routes traffic based on the geographic locations of both users and resources, with the flexibility to adjust traffic flow using bias values. Latency routing. Policy. Optimizes performance by routing traffic to the region or resource with the lowest latency for the user. Multivalue Answer Routing. Policy. Improves availability by returning up to 8 healthy records, chosen at random. Weighted Routing Policy. Provides fine-grained control by distributing traffic to multiple resources based on assigned weights. These policies allow you to tailor DNS query responses to meet your application's specific needs, ensuring optimal performance, availability, and efficiency.